Cool. So hi, I'm talking about bridging the gap. As mentioned, I'm Darcy. So kind of you can find me in the usual places. So on GitHub, Twitter, and if you have any questions after the talk, feel free to email me or come up to me in person and ask them, or just ask them in the normal session. So kind of to give a bit of context first. So like Batman, I kind of have two sides of my open source development life. So by day, I work for a Perth, Australia company called Filter Squad and release open source under them. And by night, I work for a not-for-profit called U3. So today, I'm talking kind of about stuff that came out of my experiences with work and personal. So it's starting out with a brief history of JavaScript. So kind of, I'm assuming if you're doing web development, so my talk's pretty heavy on Rails and web stuff, but with a bit of just general Ruby. So I'm assuming if you're doing web development, you probably know JavaScript reasonably well. So kind of, you've probably used jQuery or something like that, or you know it enough to be competent and develop pages. And I'm talking about kind of taking it to the next level. So I'll start off with kind of a brief history of JavaScript in terms of what that means, and a general overview of server and client-side tools that you can use kind of for development that kind of make you a better developer. So ultimately, my talk isn't necessarily about bridging the gap. It's about how you can become a better Ruby developer by using JavaScript. So kind of to get started, it's important to explain what the gap is. So the gap is what exists between Ruby and JavaScript. So most of you kind of, if you work with web stuff, you probably work with both of them. It's very rare to have a web developer who doesn't use both unless they're kind of back-end only. But there's still kind of this gap between them. They're languages that belong in different parts of the stack. And it's not necessarily something that has to be true. It's possible very easily for you to bridge that gap and to use JavaScript on both the front end and back end, and to use Ruby tools to make your front end development easier. So to get started, kind of like, it's important to understand where JavaScript comes from. So kind of JavaScript at its core is an amazingly cool language. Much like the flexibility we enjoy in Ruby when it comes to metaprogramming, JavaScript offers a lot of tools and language constructs that makes it easy to write clean, consistent code a lot of the time. It hasn't always been the case, but especially over the last few years, it's kind of advanced to a point now where a lot of people consider it respectful to call themselves JavaScript developers. So JavaScript itself has kind of had three phases of its life. So from 1996 until about 2004, we had kind of the web heyday, so the browser wars and the DHTML years. So if you used the web back then, you've probably seen at some point in time, it doesn't show up very well, but like the cursor animation, so you move your mouse around on a page, and using JavaScript, they draw a little tail on the thing. And just kind of, it was known for those kind of catchy but kind of bad effects, where JavaScript wasn't yet like a real programming language. It was used for adding little effects. 2004 until kind of 2008 is when we saw the introduction of Web 2.0 and AJAX. And kind of the web took on this whole new meaning. It was suddenly possible for you to build rich applications using just JavaScript and HTML. So Gmail is a perfect example of that. Something that, thanks to the technologies that have been brought to the browser side, you can build amazingly rich applications that aren't just static. And kind of from about 2008 to now, the most amazing part of all of this is HTML5 and the return to the server side. So over the last few years, kind of the JavaScript community has gotten a lot of exciting progress, mainly fueled by things like HTML5 and the new browser wars, so kind of competing JavaScript engines, as well as things like CoffeeESCRIPT, which makes it a lot nicer to write JavaScript. And it's important to note that server-side JavaScript isn't new. So Node, in terms of JavaScript, is kind of the new hot thing. So just kind of as a show of hands, how many here have heard of Node? Awesome. And how many of you, as Rubyists, have played with Node a bit as well? Cool. So it's a lot smaller. But I guess today I'm going to talk a bit more about why, not necessarily Node, but the tools that have come out of the community around Node are really valuable to us as Ruby developers. So I said a second ago, server-side JavaScript isn't a new thing. So when JavaScript was released in 1995, 1996, it actually started out on the server side as well. So Netscape not only integrated in their browser, they also released a web server that used JavaScript. Likewise, over the years, it's advanced in different forms. So whether it was Rhino, which is a JavaScript interpreter that runs on the Java virtual machine, JScript and JScript.NET, so Microsoft's versions of JavaScript. Or even more recently, things like node.js, AppTana-JAXA, and AppJet that all kind of make it easy to write apps in JavaScript on the server side. So like we do with Rails or Sinatra, but in JavaScript. So with all of that in mind, like, I guess I should tell the story of how I got to where I am in using JavaScript deeply with Ruby. So it all started in about 2008. Being the bored university student I was, I'm like, I want to build this amazing IRC robot. I took inspiration from a movie and book series, well, primarily book, called The Hitchhiker's Guide to the Galaxy, with a robot called Marvin. And going through it, I kind of like wanted to make this amazing thing that no one really did. Kind of IRC bots were old school. Bring it into like the Ruby age and make it amazing. So I had this bright idea, like, what if I could do JavaScript plugins? So anyone who was in the IRC channel could just give me arbitrary JavaScript code. They didn't have to know how to use Ruby. And we'd run it on a bot and they could do custom things. So for instance, you could have a robot that whenever someone said hello to it, it replied and said, hello there. So kind of the idea of like writing your robot in Ruby and then having this plugin infrastructure in JavaScript, because JavaScript was and still is kind of a language that it's not just restricted to the Ruby community. It's like most people who do web development in any form know some JavaScript. And more than that, it's everywhere. And then kind of the next part of that evolution was in early 2010, I discovered CoffeeScript and fell in love. So I was building Rails applications at the time for Youth3, the not-for-profit I mentioned earlier. And I was kind of getting sick and tired of repetitive kind of the constructs that you have to use in JavaScript where the syntax isn't nice, but the language itself is beautiful. And I discovered a plugin called Bistrocar by Jonas, in fact, which made it really ridiculously easy to plug it into Rails. And kind of, I played with it a lot, built an application on it, and eventually kind of discovered that I liked what it did, but it didn't play well with a gem called Jamit. So with that in mind, I kind of took some inspiration of my own, had a few coffees and inspired the latte. I looked at the latte art that the baristas made and created my own gem that took the CoffeeScript compiler and seamlessly integrated it into Rails to make simple, transparent CoffeeScript for Rails and Rack apps. And essentially what that means is the CoffeeScript language is written in JavaScript now, and so it takes CoffeeScript to JavaScript using an interpreter written, well, in CoffeeScript and JavaScript, which that doesn't really make much sense, but the idea is that it's self-hosting. So originally it was written in Ruby and the compiler could run on any Ruby runtime, but when it's written in JavaScript, you had to do all this extra work inside Rails applications to compile it. So I'll come back to that in a bit in the server-side stuff as kind of how that's progressed and how that's changed. But I guess the next focus is using it on the client side and how you can bridge the gap. So Rails used to have, it's kind of been phased out now, a technology called RJS. Who here has used RJS at some point in time as a Rails developer? And who here has hated themselves for using RJS as a Rails developer? So you all know kind of like how simple it was from a Ruby perspective. So RJS made it ridiculously easy to kind of do dynamic pages. You didn't have to necessarily learn JavaScript, although you should. But it kind of historically generated really horrible code. So stuff that if you wrote it yourself by hand, you probably wouldn't be very happy with it. So kind of like that was one of the early iterations of the Ruby community's way of making JavaScript easier. So kind of abstracting it out so you didn't have to learn anything, you could just work with Ruby itself. There's been a few more over the years, so a good example is Red and Redshift. It's mostly abandoned now, but Red was a library that essentially compiled down from Ruby code to JavaScript, and Redshift was their wrapper around the JavaScript document object model. So the idea being you could write all your code for your application using Ruby, similar to RJS, but instead of kind of converting it and having this middle layer, it just kind of translated the language itself. And you could use most of the constructs you knew in Ruby, which is a really powerful thing, but at the same time, in hindsight, it's a bit of a bad idea. It leads to very messy code and unexpected behavior. Kind of progressing along further, and this is kind of more from a cool hack perspective, an awesome library called Hot Ruby came out. And Hot Ruby, for those who haven't seen it, is a Ruby interpreter or bytecode interpreter that essentially it's all implemented in ECMAScript. So ECMAScript being JavaScript and ActionScript, which Flash uses. So the idea being that they went and took kind of the idea of the Ruby language and the bytecode used in 1.9 and made it possible to run that in any browser. So you weren't doing this translation from Ruby to JavaScript or generating this horrible code. Instead, you were just running your Ruby code in a browser environment. Another kind of cool hack was from Aaron Patterson, or Tenderlove, called R. Kelly. And it kind of took that idea a little further, but in the reverse. So instead of converting from Ruby to JavaScript or running it in the browser, it did the opposite. It would pass JavaScript and give you kind of the Ruby equivalent code. So we've come a long way since then. The Ruby community kind of shuns RJS now. We've learned the lessons of it. So Rails 3, for instance, introduced unobtrusive RJS, or just the unobtrusive version of Rails JavaScript. So instead of generating this horrible inline JavaScript and kind of bending it to your will, you instead use kind of HTML5 standards, so you use data attributes, and the pages ideally work the same with JavaScript and without it. Likewise, we've had, since kind of those horrible days, we've had CoffeeScript, which have many people here actually used CoffeeScript at all? Awesome. So if you haven't, CoffeeScript is a language that's inspired by a bit of Python, a bit of Ruby, and a bunch of other languages. And it's essentially kind of, it compiles it down to JavaScript, as I mentioned before. So the CoffeeScript language takes the code, it parses it, and converts it into the equivalent JavaScript, as you can see. It's probably not very readable on that slide, but it converts it to, by all accounts, not amazing, but very readable JavaScript code. And kind of it was the first language to truly do that versus things like Red, where the code was just a mess, or more recently, Google's Dart language. And one of the amazing things of CoffeeScript was they also had the idea, because the compiler for CoffeeScript to JavaScript was written in CoffeeScript, and you could hence convert it to JavaScript itself, it was possible for you to take this entire language compiler or converter and embed it in your browser. So you could include CoffeeScript in your page, and on your web page, convert CoffeeScript to JavaScript. Another cool library that kind of is less JavaScript oriented but uses the same technique of bridging the gap is Less. So Less started out as a style sheet language like Sass. So you use it on the browser side and compile it and then serve the compiled JavaScript. But kind of their way of bridging the gap was they also gave you Less.js, which is a JavaScript file that you include in your page, and then you just link to your Less files raw and unconverted. So it's kind of removing that extra step of having to go, here's my raw source code and here's what I want, convert it and then send it to the server, and you can just send that raw code to the browser and do it on the user's machine, which it's a pretty amazing step in that it's so simple and possible to do that now. It means that there's less work. So for instance, with CoffeeScript, it means you don't necessarily have to use something like Barista on the server side to compile it. You can just include the CoffeeScript runtime in your page and link to your CoffeeScript pages. And probably kind of the big culmination of this was Rails 3.1 and its asset pipeline, which it integrated CoffeeScript and Uglifier, which is a library for compressing JavaScript, into kind of most default Rails applications. I'll get onto that a bit further in the server side about how that's actually implemented. But kind of the other really, really big thing about bridging the gap that's happened in the last year or two is shared templating has kind of hit it big. So Mustache, which was written by Defunct from GitHub, it's a language that it makes it possible to write your templates kind of without any logic, and then share the templates between both the server and the client side. So you can create one set of templates for your application, and you don't have to rewrite them to use them on the front end or back end. You can just send the actual templates themselves. And it does this by having the same language specification that's a very, very simple logicless templating library, and then implementing the renderers on each platform. So that ultimately means because it's logicless, it's not programming language specific. You don't have any code inside your templates, you just have general declarations. And kind of a more modern and interesting approach, especially from bridging the gap, is Handlebars. So Handlebars is a library written by Yehuda Katz, and Handlebars is a superset of Mustache. So what that essentially means is that any Mustache template you write can be interpreted inside Handlebars. And it's supported in Rails by a fantastic plugin, so you can use them both on the front end and back end, and it will take care of everything for you. And unlike Mustache, the way it does this is that it runs the same exact JavaScript library. So when I mentioned bridging the gap earlier, this is kind of the ultimate combination, is you have this JavaScript library that does some work, and you can run it both on the client and server side without modification. And the way we do that is kind of, it's evolved over the last few years. So ultimately it happens on the server side because it's easier to write it for the browser in JavaScript and kind of convert it to something that works on the server. It's not so easy to take something that runs on the server and convert it into the browser, as we saw with things like Red and Hot Ruby. So kind of, it all kind of, I guess, started with CoffeeScript in the Rails world as a great example. There's been ways to do this sort of stuff for a long time, but the CoffeeScript gem has a perfect story of kind of the evolution. So the early versions of CoffeeScript used a Ruby-based compiler. So the actual bit that converted CoffeeScript to JavaScript was written entirely in Ruby and was easy for you to use kind of in any Rails application. You had no extra dependencies. Then at about 0.3.2, CoffeeScript converted itself to the JavaScript library I mentioned before. So no longer was it written in Ruby, and to run it, you needed a runtime. So by default, that runtime was Node. So things like Bistro, Car, and Barista. The approach we took was you call out to Node from the command line, pass it in a script, and return the results. It's a little bit finicky, as anyone who's done like command line wrappers knows, and doesn't necessarily work very well. 1.0 kind of made it a little bit better and had a standard Ruby gem called Node, which wrapped the Node library. But something amazing happened at about 2.0 to 2.2. So Sam Stevenson and Josh Peak from 37 Signals, two amazingly smart developers who you may know from things like RBENV and POW, they kind of took a new twist and they decided to reinvent it. And they used this thing called engines as an approach. Not Rails engines, completely different. But the idea that most of you using a computer have a JavaScript engine in some form already. If you're on OS X, your computer by default ships with a command line program that you can start, and it ultimately gives you the equivalent of IRB for JavaScript. So they wrote a library inside of their CoffeeScript gem that took all of these different versions and like the embedded interpreters and made them available kind of from one standard interface for calling CoffeeScript. So no longer did you have to have Node. On OS X, you could just use the built-in interpreter. Deploying to things like Heroku, you could use the Ruby Racer, which is an embedded V8 engine that basically it becomes part of your Ruby application. And it made the whole process a lot simpler because you could just add a gem and get JavaScript support on the server side. You didn't have to necessarily build and install Node like you did before. So around 2.2, they refactored a lot and they broke out this amazing library, which is kind of, I guess, the penultimate experience of all of this is called EXECJS. So Barista uses it now through the CoffeeScript gem. And EXECJS ultimately is a wrapper for all of these ideas. EXECJS is what makes it possible for us as Ruby developers to ridiculously easily use JavaScript in our server-side applications. And more importantly, it does it in a very simple and cross-platform way. So the EXECJS engine, it supports things like Ruby Racer, the Ruby Rhino, Johnson, Mustang, and a bunch of other kind of JavaScript runtimes, which they're probably just names to you if you haven't seen them before. But what it means from an implementation perspective is that it's ridiculously simple for any developer using server-side JavaScript in their Rails application to get started. The exception being Linux, like Windows and OS X, both by default ship with an included JavaScript interpreter. So you can, for instance, clone a project off GitHub, start doing your development with JavaScript, and not have to worry about adding anything. And EXECJS is smart enough to find the first one that is available out of kind of a list of priority. A good example of this is I mentioned earlier in the Rails asset pipeline is Uglifier. So Uglifier is a very, very smart and efficient JavaScript compressor that is written in JavaScript. So Uglifier will take your JavaScript code, pass it into the JavaScript abstract syntax tree, and then convert it to kind of to a very, very efficient compressed version. And Uglifier is a library that uses EXECJS to kind of wrap that JavaScript library in Ruby, so they didn't have to rewrite the compression like you do with most traditional solutions. They just take that JavaScript library and embed it directly inside your Ruby application. So I mentioned it earlier, the Rails 3.1 asset pipeline is big in this regard because it now means that by default, anyone using Rails 3.1 has JavaScript inside their application. The asset pipeline includes EXECJS for CoffeeScript and Uglifier. So if you're building things on Rails 3.1, you can straight away go and start adding kind of JavaScript code. Not necessarily that you should on the server side, but it means it's there for you out of the box. It's kind of one of the default things in Rails. And for people who've used Rails 3.1, kind of there's one big complaint about asset pipeline. Anyone here who's used it, have you ever had the issue when deploying, especially, that you could not find a JavaScript runtime? Yeah, if you search on Stack Overflow, it's a pretty common problem. So kind of one of the big fights against it was that for EXECJS to work, while on OS X and Windows, as I mentioned before, you have like built-in compilers and JavaScript runtimes. On Linux, by default, you don't. So it's kind of the developer's responsibility. And because that's all hidden away from you until you deploy, a lot of people get the issue of you go and push it to somewhere like Heroku, and all of a sudden Rails 3.1 compiles because you don't have a JavaScript runtime there. And kind of, so that, I guess, is the downside of the approach, is because it makes it so hidden away and simple. When errors do occur, they're kind of a little bit hard to find, and they hit a lot of people. So now for the cool stuff. So I talked about EXECJS and what it is. Actually using it in your applications is very, very simple. The API for EXECJS is tiny. The base method you use is execjs.eval. So you basically pass it a string of some JavaScript code, and it'll evaluate it and return you the result. So you can basically, for instance, as you see here, like create an array in JavaScript and join it. Or you can do things like have a COFFEESCRIPT that has been compiled to JavaScript and evaluate that. The more useful one, especially when it comes to using libraries, is called compile. So see here an example like JavaScript library that all it does is it has a welcome.hello method and returns hello plus name. In EXECJS, we'd basically read that JavaScript file in. We'd tell it to compile it. Compile kind of, it's a bit iffy because it doesn't necessarily compile it, but it gives us a context in which we can evaluate code. So by saying to EXECJS, compile this script, it gives you an environment where you can call methods from that script and get the results. So in the case of Uglifier, for instance, we would compile the Uglifier JavaScript library, and then we would call methods on the library with our, from our Ruby code. So in this case, we compile it and we call welcome.hello, and we pass through any arguments we want to give to that method. And it's because JSON kind of is the go-to way of passing to JavaScript. It just uses a JSON gem to convert your values. I guess further on from that, there's red.js, which is a very different thing and annoyingly confusing. Unlike the red we mentioned earlier, red.js is a set of RSPECS for Ruby interface to JavaScript. So whereas EXECJS is about running code, so like little one-off things like compiling a script, red is about giving you kind of an interpreter for JavaScript inside your application. So it's not necessarily you just want to convert something, but so going back to the IRC robot example, it's that process of then being able to kind of script things and have data and pass it back and forth. So red basically defines this amazingly detailed interface of how your Ruby program should be able to talk to a JavaScript application. And the important part of that is with EXECJS, you're not guaranteed that successive calls will return the same value if you set a variable. Because, for instance, it may use one of these interpret or runtimes, it may return the correct value, but if you're using like something like JavaScript core and OS X, because it only passes through your compiled script and the evaluated value, you may not have that persisted state that's changed in between. And kind of, so that's most of it from the perspective of integrating JavaScript into your application. But there's also a bunch of other approaches you can use to improve your development. So a good example is a library called Juggernaut 2. So Juggernaut originally was a real-time event server for Rails. What that means is you could kind of add it to your Rails application, fire up a browser, and then push messages to it. In real time, anyone with the page open will get notified, and there was no reload, no AJAX, and no polling. Juggernaut 2 was a rewritten version, and it's very important from this perspective because it's broken it out into two kind of pieces. Because Node is ridiculously good at the real-time web stuff, it has a fantastic library called socket.io, which makes basically WebSocket-like support across all browsers, including those that don't support it, possible. Alex McCaw, who wrote Juggernaut, broke it out to a Node.js kind of server that talks to the browser, and then a Ruby library that basically pushes things to Node. And the important part is, thanks to kind of a bunch of libraries that we have now, it's all ridiculously simple in terms of architecture. So you have your Ruby or any language really library. It talks to Redis and uses the capability of pub/sub inside Redis to push messages, and then pushes it to the node.js server, which the node.js server is the part that actually finally talks to the browser and broadcasts these events in real time. And the reason this is so cool is it's a great example of why Ruby isn't always the best tool for the job. As much as I love Ruby and I'm a Ruby developer, there are certain situations where you have to look at other language, whether it's JavaScript or in some cases even things like C, C++, or as much as I hate to say it, C# or .NET. Another good example of that I won't go into too much depth is 0MQ, which is a library for doing all sorts of networking operations. And it's kind of just a way that you can use it in your application to talk, not necessarily between JavaScript and Ruby, but between Ruby and other languages. So the whole idea ultimately is, what I'm trying to get at is that Ruby isn't necessarily always the best tool for your job, and most of you know JavaScript. It's a language that you work with a lot of the time, you're familiar with the ins and outs, and so bridging the gap by using tools like EXECJS, Mustache, Handlebars, is a great way kind of to expand your caliber and to use tools that are better for certain situations. And more importantly, they mean you don't have to repeat yourself and write code multiple times. You can write a JavaScript library and use it both on the client and server. Thanks, that's my talk. Questions? Excellent, thank you.
Hey Darcy,
Yep.
What do you think about Google trying with their Dart?
I think it's a very noble effort. Like, the idea is fantastic, but their initial implementation leaves a lot to be desired. So they have a fantastic example someone posted of Hello World. So the COFFEESCRIPT Hello World is about 5 or 10 lines. It's pretty simple, pretty straightforward. Because of the approach Dart takes, which is it embeds like a full language runtime, the Dart example is several thousand lines for something that's simple. And I think it's a noble idea, but doing it that approach kind of, it's something that we've seen historically doesn't necessarily work. And so I think unless kind of they can solve the problems in that, they've got a long way to go.
Thanks.